Welcome to Geometry. I have my email listed here. If you have any questions, feel free to unmute yourself anytime during the call, shoot me questions in the chat and email me here or use the Google Classroom to contact me otherwise. A little bit about today. We're going to be going through the basic fundamentals of geometry. And that includes points, lines, planes, perpendicular lines, parallel lines, angles, and a little neat thing called the parallel postulate. And a lot of these things you've probably heard about before, but it's good to get like a formal geometrical understanding of them. So I was told to do an icebreaker, and one of my favorite icebreakers I ever experienced was my middle school orchestra teacher, who gave us this chart, which says on a scale of 1 to 9, rubber ducks, how are things going today? And I'd rank myself at a 2. I just won 2 tennis matches, so I'm feeling pretty good. Oh my God, which teacher did you... Oh, sorry, this is a direct message. Oh yeah, Eleanor's super happy and excited. But yeah, I would always look forward to the rubber duck scale. A 3. Duck does taste good. I'm happy for you, Daniel. I was actually going to go get duck today, but my family decided not to. I'm going to go to Grand Swan. Okay, so a lot of 1s and 3s. I'm glad you guys are doing mostly good. For those of you who are 3, I hope your day gets a little better. And if you're a 1, I hope it stays amazing. 9, because I have 1 open. I understand you, because last night I got like less than 5 hours of sleep. I don't know what it was, but I was such an insomniac. 4 is good, a little. Insomnia is hard. I hope you can sleep well tonight. I hope you have some sweet dreams. Okay, so without further ado, let's get into this. The first thing that we're gonna approach is we're gonna use a galactic approach to geometry. So basically, I want you to imagine that the universe is the XY plane. So everything on the XY plane where we graph functions and points and lines is the entire universe. And this is important because we know the universe is something like infinite, and the XY plane you want to think of as an infinite graph. It goes on forever, even when you can't see the boundaries. Next, I want you to imagine Earth. Earth is kind of equivalent to a point. Because Earth is so small in comparison to like the entire universe, it's a good metaphor for a point. Because a point actually is just a position. It doesn't have a width and it doesn't have a length. It's just a position in space. Here's a formal definition of a point. It says it has no size or shape, just a position. And when we write a point in geometry, and when we write proofs, we write points, we notate them like a little dot and then a letter. Usually it's a capital letter. Here we have M, but common point names are like A, B, C, or like X, Y, or P actually is a, that's so weird, P for point. So now that we have one point in our universe, let's think of another one we all know, which is the sun. I'm going to plot the sun at 0, 0, the origin, because it's kind of the center of our solar system, So the sun is another point, so no width, no length. And I want you to imagine a line directly from the center of the sun to the center of the Earth. And then when we connect that line, as I have nicely drawn right here, and right here, we get a line. A line is defined as the path between 2 points. It has no width, so it's like a point in the fact that basically its width doesn't exist. All it does is it goes on forever in both directions. Let me admit someone. It goes on forever in both directions. And So I want you to add another point to our little graph. We're going to use the moon. And we're going to plot the moon right here at 1, 1. Oh, sorry. I went a little out of order for my slides. So if we think of this point, let's call the sun point S. Let's call the earth point E. This segment of the line between them, we can call the line segment SE. Sometimes when you think of line segments, you kind of think of the line segment being the entire line, but it's not really the case because a line continues on forever, and the line segment is only this portion of the line. So the official definition of a line segment is that it's a portion of a line which has two endpoints. In this case, they're A and B. And when we write line segments, we write them with the 2 points that define the segment here, and then a little line symbol over the top. So in our galactic analogy, I wrote here, this would be line segment SE with a little line symbol over the top. Okay, so now let's get into rays. If you have any experience with physics, a ray is kind of like a vector. The formal definition is a ray is a portion of a line which has one endpoint and extends forever in one direction. So it's kind of like half of a line if you think about it. But here we have ray PQ, which is defined by the endpoints, by the points P and Q. And you can see this little arrow notates that it goes on forever in that direction. And we write it like this, just like these two endpoints and a little arrow symbol on top, which is actually really fun to write. Okay, so I have a couple of examples. I want you guys to just go through and classify these: line segment, ray, point. I'll do the first one. For example, this is like a line notated by the points CD. So this would be a line segment. And we call it segment CD. So if you have like a scratch piece of paper, you can write down the answers there, but I'll give you like 3 minutes maybe, and then we'll reconvene and I'll ask you guys what your thought process was. Okay, guys, let's reconvene. Does anybody want to share their thought process? You can raise your hand if you would like to explain how you classified some of these.
I think Anna raised her hand. I don't know if you can see.
Yeah, I see it. Thanks, Anna. Can you explain, can you maybe do the second row, like 3, 4, 5?
Okay. Also, can you hear me? Because my mic might be kind of.
Yeah, I gotcha. I can hear you.
So, number 3 is line QR because it starts at Q and goes in the direction of R, so that's QR.
Yeah, you're right. It's defined by QR. But this is actually, see, it would be a line segment if it was these two. But because we have this little arrow, which I think you understood because you said it goes in the direction of QR. So it's called a ray. Thank you, Anna. Can you explain number 4 for us, please?
Yeah, number 4 is pretty easy. So it's just I forgot what that was called. What was it?
You're good. You're good.
It was called a point. So that point is called L. So
yes,
it's L.
Point L. Thank you. How about number 5?
The number 5 is a line segment. It can be either line segment NO or ON.
Perfect. Thank you. That's a good point. So when you have like a line segment, it doesn't really matter what order you define the line segment. So this could be line on or line no. Thank you, Anna. I got this wonderful direct message from Daniel, who did an amazing job at classifying all of these. So let me pick out where he said number 6. Actually, let's just go through his answers. Daniel said that number 1 is segment CD, number 2 is ray XY. Daniel, do you want to unmute and tell us your thought process for that? It's all good if you don't want to. But yeah, this is ray XY because we have these 2 points, X and Y, that define the ray. And it has a little arrow continuing this direction. So yeah, that's a ray. Number 6 we have here. Oh, sorry, Daniel. Thank you. Thank you for your answers though. Number 6, we have a line. This is line, and this segment right here would be called UV, like line segment UV. But we know it's a line because it has arrows indicating that it continues forever in each direction. Does anybody else want to explain number 7 and 8? How about Sophie? Do you know how to do number 7?
Well, it's a line because it goes like in both directions.
Perfect. Thank you so much. And then the segment here, if we just had this portion, would be HI. And then number 8 is another ray that goes on in this direction. Wonderful job, guys. Thank you so much. Now let's add the moon to this mix. And I want you to picture a line from the moon to the earth. So right down here. And that is not a good line, but what that makes is a perpendicular line. So a perpendicular line is lines that intersect or meet at one point. So the lines, they intersect and meet at a right angle. So it would be exactly a 90-degree angle, which we notate like this, like a little half square. So there are like a couple classifications of pairs of lines. We have perpendicular lines for one, which meet at an exactly 90-degree angle. And then there are also intersecting lines, which are just 2 lines that intersect. Here they would intersect at this point. And the final classification of line, I want you to imagine, we know the Earth rotates around the sun. So let's say the Earth rotated over here. Now we have the Earth, Sun, and Moon, and let's draw a line from the Moon to the Earth once again. bad line once again. And here we have parallel lines. You guys have probably heard of these before. I think they're super cool. We notate them with little arrows like this, indicating that they go in the same direction. Cool thing about parallel lines is we know that lines continue on forever. But parallel lines, they continue on forever and they never touch each other. That means they're at exactly the same slope. So they could be at any slope in this plane. But if they're parallel, then it doesn't matter if they go on forever, they'll never touch. But say we have like a line like this, even though these two lines, this line and this line, don't touch each other right now, we know that because they continue on forever, they will eventually cross paths somewhere to the right side of my screen here. So I have another quick exercise. You can just write down the numbers. I have 1 for parallel, 2 for perpendicular, and 3 for intersecting. It's also important to note that a perpendicular line could also be an intersecting line. So I'll give you guys maybe 2 minutes to work on this, and then I'll ask people to share. Okay, guys, let's reconvene. I'd love to hear from some people who I haven't before. Does anybody want to share their findings for, say, the first 3? Go ahead and raise your hand or just unmute. Anna, can you explain your thought process?
Okay, so the first one, since both of the lines are going at the same angle, and so they're going to never touch, so they're parallel.
That's perfect, Anna. Thank you. That's exactly the definition, like word for word. How about this one?
So this one, both of the lines are intersecting, but it's not at a right angle, so it's an intersecting line.
Yes. Beautiful. How about this one?
Again, this line, both of them are going at the same angle, so it's a parallel line.
Thank you for bringing up angles. We're going to get into those a little bit later. Thanks so much. Amanda, can I hear from you? Do you want to do the next three?
Can you hear me?
Yeah, I got you.
So that one is an intersecting line.
Yeah. You're breaking up a little bit, but I can still hear you. How about this one? I think I know what you're trying to say. Sorry, your audio is a little bit. These are perpendicular. Thank you, Amanda. If I can spell it right. So yeah, they meet at a 90-degree angle, which is kind of hard to see from this graphic, but yes. How about this one, Amanda?
Parallel.
Yes, these are parallel. So we can write a little.
Parallel?
Yes. Okay. I want to show some appreciation to Daniel, who sends all of his answers in the chat. And for this row, he said this was intersecting lines, which is exactly right. These ones are parallel. These ones are perpendicular. Okay, I think you guys got the idea. Let's move on to our next topic, which is angles. So thank you, Anna, for transitioning us so nicely. Here I have this circle graph. In a circle, there are 360 degrees. Angles are measured in degrees, and they're sometimes measured in something else called radians. But right now we're going to focus on degrees. You've probably heard of it, like a right angle is a 90-degree angle. Some more angles that you might not have heard of, a straight angle is a 180-degree angle. So in each line, there's like 180 degrees from one side of it to the other. And if we go 3/4 of a way over the circle, you'd make a 270-degree angle. And if you continue the full way, that's the full 360s. So I'm gonna get into some classification. So when an angle is less than 90 degrees, we call it an acute angle. And when I first heard that, I was like, oh, so it's cute. It's small and it's cute. But I don't think that's whatever mathematician who named it. I don't think that was their idea. We've talked about right angles a lot. They're angles that meet at exactly 90 degrees. And we make up a little box. Obtuse angles are angles that are bigger than 90 degrees. Straight angles I just talked about, they're exactly 180 degrees. And reflex angles are angle measures between 180 and 360 degrees. So these are going to be angles that are like on the outside of the main angle, if you know what I mean. So here, if we have our obtuse angle, this would be called an interior angle. And then the reflex angle that coordinates with this interior angle would be this angle, which is over 180 degrees. So yeah, anything that's bigger than this line, anything that goes over a line like this, that is a reflex angle. Okay. So I have a couple angle classification problems. I'll give you guys a couple minutes. I'll also like keep the definitions up so you can see. That'll make it a little bit easier. But yeah, I'll give you guys like 2 minutes. Feel free to give your answers in the chat. Yeah.
What's the angle that measures between 180 and 360 degrees called again?
It's called a reflex angle. My bad, I didn't have the names. There you go. Thanks for asking. Also, another bit of information that I did not tell you guys yet is an angle that's a full 360 degrees. It's called a full angle because it's a full 360. Super creative, yeah. Okay, guys, let's talk through some of these. Does anybody new want to explain their thought process from the first three? I'd love to hear from some of you. Peony, please share.
The first one is acute because it's less than 90.
Yeah, and it's just so adorable. Yeah. Sorry. Not funny.
And then the second one is a right angle.
Yes.
And then third one is obtuse.
Yes. Perfect.
Over
Can you do the
90.
next two too?
You want me to do the
Yeah, go ahead.
okay. Shoot, I forgot the name of that one.
You're good, you're good. Think of it as like, you know, a line has a quality. It's like a line is
Straight.
yeah, a line is straight, a straight angle. How about this one?
Reflex.
Yes. Thank you so much. Anna, can you explain the last couple of these?
So that one is a reflex angle because it's over 180 degrees.
Perfect. Thank you. How about this one?
This one is an obtuse angle because it's over 90 degrees.
Yes, exactly. How about this?
This is a full angle because it's 360 degrees.
Oh yeah, that's a full 360. What about this one?
And this
Easy
is
one.
a right angle.
Perfect. Thank you guys so much. Okay, now that we've covered a little bit about angles, let's move on to angles as how they relate to triangles. So the most important thing to know is that the sum of all the angles inside a triangle is always equal to 180 degrees. It doesn't matter what kind of triangle it is, it's always 180. So I'm gonna do the first example for you guys and then send you off on your way to calculate some angles. So on this one, we know this angle here is 35 degrees right here. And we know this angle, because it's marked as a right angle, is a 90-degree angle. So to find this angle here, let's call it X. We would take 180 degrees, which is the total amount of degrees in the triangle. And then we'd subtract 35, which I'm not great at arithmetic, but I think that's 145. And then we'd subtract the 90, which would leave us with 55 degrees. So we know this angle X is 55 degrees. Okay, this one might be a little trickier. There's some math and basic subtraction is kind of hard sometimes. So I'm gonna give you guys a little bit longer, maybe like 4 or 5 minutes. Just solve for the angles that are unmarked. Okay, guys, so I lied. I feel like I need to save some time to get into the more fun stuff. So let's just go through number 2, 3, and 4. Does anybody have those done and would like to share? Thank you, Anna. Can we do number 2?
So number 2 is 120. So I added 28 and 32 together, which is 60. And
Nice.
180 minus 60 is 120. So the answer is 120.
Nice, nice. I think you guys get the idea. How about let's do this one? This one's kind of special. We know it's isosceles, so we know these two angles are the same. Anna, do you know how to do this?
Yeah. So since both of the angles are the same, I did 180 minus 124, which is, wait a sec, I think that's 56. Yeah, it's 56. And 56 divided by 2 is 28. So both of those angles are 28.
Nice, good math. I hope everyone understands. Also, feel free to just like shoot me a question and say like, I don't get any of this if that's where you're at, because I've definitely been that kid in math class where I just didn't understand anything. But thank you, Anna, so much for sharing. I'm gonna move on from these. I think we understand. And I'm gonna move on to this fun problem. So when I first looked at this, I was like, wait, how do I do that? So I want to give you guys a couple minutes, think it through, and then I'll call on someone who I haven't heard from to explain their thought process. It's kind of a cool problem. We have more of these coming up soon. William, do you want to talk us through?
No.
Okay. Do you have any ideas though?
Wait, am I really? Oh, shoot. Wait. It's unmuted.
Okay. Does anyone have any ideas? I know Daniel got the answer already, which is very cool. It's too bad he doesn't have a mic to explain his thought process. How about May? Do you have any ideas how to solve for this angle, this pink angle? Okay, May and Daniel both agree on the same answer. So let's walk through this together. I think the first step would be to solve for this angle right here. Also, it's good to note that when we talk about angles in geometry, we write them with this little triangle symbol and then with the points that define the angle. So in this case, it would be angle YZX that we're trying to find. So that would be 180 minus 52 minus, wait, I'm going to use Anna's strategy here. 52 plus 58, which would be 110. So it would be 180 minus 110, which would equal 70. So this angle here would be 70. And then we know that this angle is 180 minus 70. So that angle would be 110. And then from here, we know that this angle right here that we're trying to solve for, angle ZYP, would be equal to 180 minus 110, which is 70 minus 29, which is 41. So thanks, May. You got the right answer. I'm sure you had a great way of doing it. Might have been different from mine. This is the next problem I have. I think you guys are really getting this, so I'll just give you like a minute and then we'll come back and talk about it. Okay, let's reconvene. Oh, sorry, I forgot to mention what we're trying to calculate, but I was thinking we should solve for this angle and this angle here. So let's start with ZXV, angle ZXV. We know that is equal to 180 minus 55, which is, let me do some quick math, 125. I think that's right. And then we know that, now we know, because this is 125 degrees, we know angle VXW would be equal to 180 minus 125 degrees, which equals 55 degrees. But where do we see 55 is familiar from? From this thing over here. So we basically just proved this little theorem that says angles like opposite from each other in intersecting lines are always equal. We write equal angles like this. So we put like a little line through them to say that this angle is equal to this angle. And we also know from this little theorem that these two angles are equal, but because we know that this angle is not equal to this angle, we can use two lines to say that these two are equal. Okay, let's get you guys some harder stuff. This is when geometry first started sparking an interest to me. A parallel postulate is, let's go back to our galactic model and imagine a line from the sun to the moon. A parallel postulate is basically when we have two parallel lines and then a line that crosses, it intersects both of them. This line right here is called a transversal. That's not extremely important, but it's good to know, you know. And there's a lot of cool things that happen with the angles surrounding a parallel postulate. So let's get into it. Here we have another set of parallel lines. So from the theorem we just talked about, we know that angles A and C are the same. We know that angles E and G are the same. We know that angles B and D are the same. And we know that angles F and H are the same. But the thing is, because this line intersects both parallel lines at the same slope, because the parallel lines are at the same slope, we actually know that angle E is equal to angle A, which is equal to angle G, which is equal to angle C. Same thing with all of these angles here. And that could be used for some really, really cool practice problems. So here, I'm going to walk you guys through this one, and then I have a little harder one coming up. So let's solve for all these angles. Let's solve for angle A first. We know that angle A is 180 minus 113 degrees, which would be equal to 67 degrees. And because we know angle A is 67 degrees, we also know angle B is 67 degrees. And we also know angle Z is 67 degrees. And we also know angle X is 67 degrees. Same thing with angle C, because it's opposite of this angle 113. We know that this is 113 degrees. And because angle C and angle Y are opposite exterior angles, Angle Y is also 113 degrees. Angle W is also 113 degrees because it's opposite from angle Y. So a lot of cool things can be proven with this, including this. So we know that these two lines are parallel. These two lines are parallel. And we know that this angle here is 180 degrees. So see if you guys can find X and Y. I'll give you like 2 minutes. Okay, guys, does anyone have any ideas? Daniel has wonderfully messaged me the answers, so we can see if your guys' answers line up with Daniel's. How about Andy? Do you have any ideas how to solve for X and Y? None. How about Peony? Do you have any ideas?
Oops. Yeah. So 180 minus 118 is 62.
Right, so this angle here would be 62.
And y is like, oh wait, I mean x is like the same as,
Yeah,
and then 180 minus 62 is 118. So those are like the same, y and
yeah.
that one. Yeah.
Thanks so much. So yeah, we know that this angle here is 62 degrees because it's 180 minus 118, and it's corresponding interior angles with this angle X, which is also 60 degrees. And then we can do from there 180 minus 118, which is Y. I'm gonna skip these. These are kind of easy, and I have a little Kahoot at the end, so I'm gonna save time for that. So how about this problem? The goal is to solve for X. I'll give you guys 2 minutes. So I'm getting a couple different answers in the chat here. I'm getting from Anna that X equals 67, I'm getting from Alex that X equals 62, I'm getting from Daniel that X equals 6. Alex, do you mind taking us through your thought process? Because it's always fun to see that. Yeah.
That was for the other problem.
Oh, the other problem? That's my bad. How about Anna? Do you want to talk us through?
No.
No?
Yeah.
Okay.
It's kind of complicated to explain.
I understand you. Yeah. How about Amanda? Do you have any thoughts? Okay. Well, let's work through this together. I'm sorry for taking a real like 0 to 100 kind of practice problem approach, but hopefully this will clear it up. So I think the first step that we can do is solve for this angle here. This angle would be equal to 180 minus 5 plus 10x. If you guys haven't done algebra before, I completely understand that, but this is just like kind of like mid-advanced algebra. So when we subtract a negative sign, we actually add it. So now we have 185 minus 10x. It's confusing, but when we have a minus, it kind of negates both of these. So that turns into a plus and that turns into a minus. So we know this angle is 185 degrees minus 10x. And so let's do the same thing for this angle right here. You know, I actually just thought of like a way faster approach, but I'm going to do this first. So I'm sorry, Daniel, I wish I could let you explain, but maybe like send your thoughts in the chat and I'll go over those. So this would be 180 minus 9x plus 1. So we know this angle is 179 minus 9x. And then because we know that these two angles are equal to each other, because these lines are parallel, we can set them equal to each other here. So let's say 185 minus 10x equals 179 minus 9x. And then from here, let's add the 10x to both sides. So now we have 185 equals 179 plus x. And now let's subtract 179 from both sides. And then we get x equals 6. So I hope that cleared it up, but I understand it's like confusing if you've never done anything like this before. And the easier way that I was talking about was because we know these are parallel lines and this line cuts through them, we know this angle is equal to this angle. And I can't believe I missed this. But yeah, Daniel's explaining this right now in the chat. We know these two angles are the same. So we can say 9x plus 1 equals minus 5 plus 10x. Solve that real simple. Let's subtract 9x from both sides. We'll get 1 equals minus 5 plus x. And then we'll add 5 to both sides. We get x equals 6. My writing really took a turn there. Yeah, Daniel basically just talked us through. I think it was a direct message to me, but trust he said what I said. Here's a little bit of a challenge problem, and I feel like that might look a little intimidating, but I think I'll include it on the optional homework to see if maybe you want to try your luck at solving for x and y. Oh yeah, I forgot to mention, I'm gonna have like optional practice problems if you want to check your understanding. And I'm gonna assign construction videos. Construction is basically like creating shapes, geometric shapes, and it's really fun. So if you guys have access to a compass and protractor, that would be amazing. And I understand if you don't, it's perfectly fine. Here's another practice problem I think I can include on the homework, but I think it's Kahoot time. So let me get this started up. I have it right here. Oh my God, wait, I'm giving it away. Oh my God. I need to stop screen share. Hold on, let me get to my create. Oh, sorry guys, this is new to me. I'm not a teacher. I feel like a teacher though with all my technological problems. Okay, if you guys have a device you can join on, including like whatever you're on right now. Or if you have like a phone or something. Hey, Alex. Hey, May. You guys should like bring back fun names. Remember in like elementary school when we like have fun names? All my teachers were like, you have to put your real name, but I don't know, have fun with it.
I am in elementary school.
You are?
Yes, I'm in 5th grade.
What? How is it? Is it fun?
I haven't started 5th grade yet. School starts
Oh yeah.
in 2 days.
I forgot about that. How was 4th grade though?
4th grade was good.
Nice. What school do you go to?
I go to a school called Soap Creek in Georgia.
Cool. Georgia. Alex, you're also in elementary school. How is your elementary school experience? Okay. May I get you? I get you. I always feel so old compared to everyone else. Okay, let's start this up. I think I did, Daniel. Yeah. So this is kind of a trick question. I'm sorry for putting line segment on there because you guys are technically right. Those would be line segments, but yeah. I think mainly I was trying to get at that they intersect and that they're perpendicular. Whoa. I think it might have been just the time limit and the stress. Good job, May. Let's go. But yeah, basically 180 minus the 90-degree angle, which would be 90 minus the 25 would be equal to 75 degrees. Oh yeah. Good job, guys. I know we're approaching on time, but there's only a few left. Nice job, guys. That time limit was hard, but nice job. Oh my god, there's a fight for first. Good job, Ducky, and everyone else in the leaderboard. Quickly get this in. Oh yeah. Oh yeah. Let's go, Anna. One last question, guys. Thanks so much for joining me this time. I had a really fun time. Thanks, guys, so much. Let's see who the winners are. Let's go, May. Let's go, Anna. Number 1. Let's go. What did you say? Sorry, I don't actually know. I'm going to stop my screen share. I know I went a little over, but thanks for joining me through this, and thanks for staying. Even when I left, I went over. Thanks, guys. I'll see you next week. Thanks.